Hello, welcome to our session. So, panibagong content. This time, let's discuss all about the branch circuit calculations for the single motor. So, when we see motors, those are machines that produce motions or power for doing work. So, yun yung definition ng motors. So, itong mga motors is maraming contribution sa industry, lalo na sa power plant. And then, meron tayong gagawing branch circuit calculations. If nakita nyo, meron tayong this one, the schematic diagram. So, from here, ito yung bus bar kung saan nakatap yung ating motor. And then, itong number 1, this is the branch circuit conductor, or ito yung sinasabing wire. And then itong branch circuit conductor is the same with this. Itong sa baba, saka ito, the same lang sila. And then sa number 2, meron tayong OCPD, or known as circuit breaker, or branch circuit, short circuit, and ground fault protection. Itong number 3, this is the branch circuit for overload protection. And then itong number 4 is ito yung ating motor na load, that is 3 HP, 230 volts, 3 phase. And then meron siyang service factor na 1.15. And then yung full load ampere niya sa nameplate, meron siyang 9 amperes. And then squirrel cage induction motor. So this time is we do calculations. Paano ba to determine para mapagana mo ng maayos yung motor, or mapatakbo mo ng maayos. So first, let's solve the branch circuit conductor. So paano ba yung tamang size ng circuit conductor para sa motor na to? Okay, so merong sinabi yung code, basahin natin. Ang sabi sa PEC 4.30.2.2 per single motor, ang sabi dyan, so conductors that supply a single motor used in a continuous duty application shall have an ampacity of not less than 125% of the motor's full load current, rating as determined by 4.30.1.6. So ang sabi dyan that yung single motor or individual, pag nagamit mo siya in a continuous duty, tuloy-tuloy yung operation, so dapat daw yung ampacity is not less than 125% of the motor's full load current. But ano ba yung motor's full load current? So on the table, itong table 4.30, 0.14.4, the full load current 3-piece alternating current motors. So yung ating motor is range just from 230 volts. So itong table is pwede natin gamitin. And then yung ating motor is induction type, squirrel cage. And then if you look on this column, meron itong sa 5 HP. So if kunin natin yung full load current, and then yung system voltage na ginamit is 230. So if you look on the table, lumalabas na yung 3 HP, yung full load current niya is itong 9.6 amperes. So let's use this value para ma-determine natin yung ampacity ng branch circuit conductors. Based doon sa data na nakuha natin kanina, that itong 3 HP na 230 volts, 3 phase, so yung kanyang full load current in amperes is 9.6. And then to determine itong size of conductor, so the full load current multiplied by 125%. Okay, so to continue, so for the size of conductor, yung ating full load current is 9.6, and then let's multiply by 125%, or we call as 1.25. If you look at the calculator, that is 9.6 times 1.25. So meron tayong answer na 12 amperes. Okay, so let's use that value. We have 12 amperes. Okay, so ito yung reference natin to size the branch circuit conductor. So meron tayong table na titingnan, and then from the table, table 3.10.2.6 B16, this is for the wire ampacity. So yung gamit nating wire is tanso or copper. So ito yung summarize ko na table galing doon sa PEC. So on this column, this is the square ng wire, and then on the second column, ito yung type of wire, THHN, THWN, THW at saka THWN. So at 75 degrees Celsius, so yung ating doon sa computation kanina, meron tayong 12 amperes. So if you look on the table, so itong 2.0, ang kaya niyang ampacity is 20 amperes. And then itong 3.5, ang kaya niyang ampacity is 25. So for me, so much better to use this 3.5 because mas matibay siya ng konti sa 2.0. So if hawakan mo yung 2.0, masyadong malambot. So much prefer to use the 3.5 square mm. Based doon sa table kanina, that much better to use the tatlong 3.5 square mm THWN na wires, and then kaya niyang ampacity is 25 ampere. So pasok pa rin siya. Next is mag-size up naman tayo itong number 2, or known as OCPT or circuit breaker. So meron tayong codes na babasahin for that. From the table, 4.30.4.2, this is for rating or setting for individual motor circuit. So at B, for all motors, the branch circuit, short circuit and ground fault protective device shall be capable of carrying the starting current of the motor. So meron tayong table. This is the maximum rating or setting of motor branch circuit, short circuit and ground fault protective devices. So the first column is ito yung type of motors that yung gamit natin is squirrel cage. So ito, and then yung gamit nating circuit breaker is ito, inverse time circuit breakers. So pag gamitin mo tong inverse time circuit breaker, then dapat yung multiplier mo is 250 or 250. So let's use this value to size up our ground fault protective devices. Based on the table kanina, that yung ating ground fault protective device, so yung full load current expressed in amperes multiply by 250%. So solve natin yung ating full load current is 9.6, then let's multiply by 2.50. Okay, so by using our calculator, that is 9.6 times 2.50. So meron tayong 24 amperes. Okay, so ito yung ating gamiting reference to size our ground fault protective device. So let's look on the table kung ano yung magiging pasok dyan na rating. From the table, 2.40, 0.1, 0.6 for standard ampere ratings. So this is for fuses and PEC strip circuit breakers. So the standard ampere for fuses, ratings for fuses and inverse time circuit breakers. So 15, next is 20, next is 25, and then next is 30, and then so on. So dun sa kanina yung ating nakuha is 24 amperes, so the closest is 25, but I don't know if meron kang or mabilis kang makahanap ng rating for that. Commonly, the next is 30 amperes, which is available sa ating market. So mas prefer ko to use this 30 ampere na inverse time circuit breakers. From the table yung kanina, so if yung ating OCPD or yung nakuhang ampere is 24, so the closest is 25, so the next size up is 30 amperes. So use amperes, circuit breaker 230 volts, 3-phase ka inverse time circuit breaker. So next is let's find out itong number 3, or we call as branch circuit overload protection. So meron tayong code na basahin for that. From the PEC 4.30.3.2, this is for continuous duty motors. So letter E, for more than 1 horsepower, so each motor used in a continuous duty applications and rated more than 1 HP shall be protected against overload by one of the means. So and then itong number 1, for the separate overload device that is responsive to the motor current. So this device shall be selected to trip or shall be rated at no more than the following percent of the motor nameplate followed rating. So malinaw dyan motor nameplate followed current rating. So if yung motors mo, so mark with a service factor of 1.15 or greater. So yung size mo ng overload device, so dapat naka-multiply siya ng 125%. So if yung motors mo with a mark temperature rise 40 degrees Celsius or less, so ang factor is 125%. And then all other motors is 115. So from that, yung ating 3 HP motor have 1.15 service factor. So pasok tayo dito. So therefore, yung ating gamiting multiplier is 125%. Okay? Malinaw yan. From the code, yung kanina, that to size yung branch circuit overload protection is kunin mo yung followed ampere niya sa nameplate, and then multiply mo ng 125%. Okay, so ito yung ating followed ampere sa ating nameplate. Okay, so after that, let's multiply this 9 times 1.25. Okay, so by using our calculator, that is 9 times 1.25. So meron tayong value na 11.25 amperes. Okay, so now we can use the 12 amperes maximum for the branch circuit overload protection. So ganun mag-size ng branch circuit overload protection. Kunin mo lang yung followed amperes sa nameplate, and then i-times mo lang siya ng 125% if yung service factor mo is 1.15. We're almost done with our computations, that lumalabas itong 3 HP na 230 volts 3 phase. So yung ating branch circuit conductor, ito yon, is tatlong 3.5 square mm na THWN wires. And then itong branch circuit conductor is the same with this wire, saka itong sa after ng overload protection. And then yung ating OCPD or circuit breaker or ground fault protective device, lumalabas na use 30 amperes, 230 volts 3 phase, saka 3 poles inverse time circuit breaker. And then sa ating branch circuit overload protection, so meron tayong nakuhang 11.55 amperes. So use 12 amperes as maximum. So ganito mag-size up or computations ng mga branch circuit for a single motor. Next, siguro gawa tayo ng content paano naman yung mga multiple connected motors sa isang panel board. So paano ulit yung magiging branch circuit calculations ng multiple motors. So I hope may natutunan kayo sa ating discussion. So pag nagustuhan nyo itong session na to, so please subscribe for more updated videos na i-upload ko. So salamat.